Greetings, traveler. I'm the calculus cleric, and today we're working with logistic equations. So, a specific problem is that Sunset Lake is stocked with 2,000 rainbow trout, and after 1 year, the population has grown to 4,500. Assuming logistic growth of the carrying capacity of 20,000, find the growth constant k and determine when the population will increase to 10,000.
Okay, so let's dive right in.
Okay, so the basic format of this is a multiple step problem. So first they want us to find growth constant k and determine when the population will increase to 10,000. So here they're asking us for some kind of time, and here they're just asking us for k. And our givens is that it is currently 2,000, and after 1 year it grows to 4,500. So this is when t is equal to 0, because this is currently now, no time has passed. And t is equal to 1 over here. And it gives us that our carrying capacity at 20,000. Okay, so the specific equation we're going to use is y is equal to a over 1 minus e to the negative kt divided by c, where y is the population after a certain set amount of time, a is the carrying capacity, k is our growth constant, t is time, and c is some constant. Okay, so first steps first. Normally, when we have a logistic equation problem, the first thing we want to find out is c, especially if they give us t is equal to 0, because it'll make it really easy to isolate c, and then we're going to need that to solve for any of the other variables itself, since c right now is currently a mystery number. So using the 2,000 rainbow trout they gave us, 2,000, that goes into our population. Yeah, and the carrying capacity, 20,000, so that replaces a. 1 minus e to the negative. They're not giving us k either, but that's okay, because when time is 0, we replace t with 0, and so that'll effectively eliminate k, leaving us with only one variable to solve. When we are solving for c, let me write this out again. E to the 0 is just 1. 20,000, not 2,000. Okay, and then we just use algebra to solve this problem. Reciprocate, multiply both sides by 2,000, cancel out the zeros, simplify that some more. So c is equal to negative 1 over 9. So our new equation, so divided by negative 1 over 9, and so that'll equal to positive 9 in the front, and then can eliminate that. So the negatives cancel out, and because of it's divided already, and if you divide by a fraction, you just multiply by the denominator. Okay, so that's our new equation. And let's move on to the second part. The second part is after 1 year, the population has grown to 4,500. So we can use this to find k, because this will make it so that t is equal to 1 and not 0. So k won't be eliminated, but it will still remain. 4,500 is equal to 20,000. Because t is just 1, it's just negative k. And we do algebra once again to solve for k. The zeros can cancel out, and then we can simplify this some more. And that's 31 over 81. And now we have to isolate k by itself. But this is negative k as an exponent. So we want to reciprocate everything first, so that way we can make that positive and flip it over like that. If we multiply both sides by natural log, we can get k by itself, because natural log of e is just 1. So k is equal to ln of 81 divided by 31. Okay, so that's another one of our answers. And now we have to move on to the third step, which is determine when the population will increase to 10,000. Okay, so now we know our k and our c. We just have to plug in 10,000 into our y. So that goes into the population. And then we replace everything just like before. But now we also have some new numbers to plug in. So now we're solving for t, because we're looking for what time will the amount of trouts become 10,000. Using algebra to solve it all out again. And divide both sides by 90,000. Cancel out as many zeros as possible. And then we reciprocate to get rid of the negative sign on the exponent. And then from here, we can take the natural log of both sides. And then natural log of e is just 1. So it leaves us with ln 81 over 31 t is equal to the natural log of 9. And then from there, we take this and then we divide both sides by the natural log of 81 over 31. And that is actually our t value. If we want to know this in actual like numbers, we can plug this into a calculator. And that is approximately 2.288 years. Okay, and we solve the problem.
Knowing this, you'll be making waves in logistic equations in no time at all.